Welcome back to the VMworld vBrownbag Tech Talks. Glad to have everybody here today. My name's Tony Foster. I'm a vExpert, a EUC champion, NVIDIA Grid community advisor. The list goes on and on and on. And I work at EMC doing technical marketing. Today we're going to have some fun, and we're not going to be talking about EUC for all of those people who keep giving me grief because it's EUC. Today we're actually going to be talking about redefining data centers with 3D or virtual reality or augmented reality or any of those concepts that you've probably heard thrown around throughout the VMworld keynotes and the rest of the sessions that have been going on at VMworld this week. So you've probably got to experience a lot of the different 3D capabilities. They're everywhere. You've got Oculus Rift, you've got RealD movies where you go into a movie theater, put on some glasses and stuff starts popping out at you. You've got Google Glass where you can augment the reality around you and see different things. The big data that's out there, that's being handled a lot with 3D graphics accelerations such as the NVIDIA Grid GPU. They're processing stuff crazy in there. And we even have it in PowerPoint. Case in point, the little box there, all rendered in 3D graphics inside of PowerPoint. So it's absolutely everywhere. But you're not seeing this applied in the data center at this time. It's all being applied to the external use cases. So how is it the GPUs make all of this stuff possible? Well, there's a very good comparison. In fact, there are two very good comparisons of how this works. NVIDIA has a wonderful website for those who like Mythbusters, where Jamie and Adam from Mythbusters actually go through the difference in a very cool visual way. And then there's my less than magnificent way here. So with the CPU, it's typically a single-threaded process. Everything sits there and operates on a single thread, maybe a few threads, but it's all first, then second, then third. Whereas with the GPU, it actually sits there and starts building out a matrix structure of processing. So it'll start at the top and just pyramid down till it can finish calculating everything, which is absolutely great for all those things that we talked about before. Rendering 3D designs, processing big data sets where you want to calculate how different things are working, large number calculations that you see in big data, all those different things. And that's the difference between GPUs and CPUs, is CPU we're doing a single thread processing, whereas with the GPU we're going to do multiple threads in sort of a downward pyramid fashion. So let's take this into the data center. Let's figure out how we can actually apply this GPU processing capability in our data center. One way we can apply it is by allowing people to visualize what the cloud looks like. So a lot of people are very dimensional thinkers. They like to be able to see and visualize what they're working with in multiple dimensions. And this allows people to put on a headset, visualize their cloud, move things around in their cloud, and discover how they work, how they fit better together. A second way that we can really explore using GPUs and 3D technology in the data center is by visualizing inside the data center, augmenting the reality of your data center. How cool would it be to put on a holodeck and walk into your data center and be able to see a heat map in your data center of what's hot and what's the hottest thing in a rack, instead of just seeing, well, my rack is hot at this temperature. I can see what in the rack is hot, what throughout the aisles are hot, and I can start optimizing that. Or where I have cables unplugged, where I have bad disk, I can start taking the matrix and information from within my data center and turning that into visual cues as I go through my data center to maintain it, to repair it. And then the last area is the machine learning aspects. If you look at a data centers generate huge amounts of data. Wouldn't it be great if we could take that data, do self-healing, self-analytics against it, so that my cloud, my infrastructure is automatically adjusting itself to work the most efficiently possible, and is notifying me in regular common language what's happening in the data center. Hey, you've got a bad disk drive, go replace it when you have time. I've already moved all your workloads off of here just in case something else happens. And we can see a little bit of that in the diagram I have on the right of a augmented machine learning system. So let's dig into this idea a little bit more, because this is one of the more intriguing ones with data center learning. So when we apply a GPU into a data center learning model, how much data is your data center producing? And if it's actually producing that much data, are you capturing all of that data? And how is that being processed? With the GPU, we can start gathering more data. I don't know too many people who actually keep heat logs on their equipment or fan speed logs on their equipment. If you start storing those with the GPU, your GPU can start using learning algorithms to actually figure out and be predictive in when different pieces of hardware are going to fail. So you have that. You also have the time it takes to look at all of this. GPUs can do that very, very quickly and can become very, very smart in weeding out the irrelevant stuff. And then there's the time it takes to respond. GPUs can respond like that and move workloads and stuff off with the help of DRS and other great features within VMware. So why not let the GPU be smart about it and move things off for us? Plus, they can get very, very accurate. The more they know, the more they learn, the more information they get, the more they can start moving those machines in an appropriate manner that provides the best user experience for your users, for your data, for your applications. A great example of all of these different ways to apply GPUs, and by the way, this link is not safe for work, so don't go watching it at work, is thewebsiteisdown.com. And just to give you the synopsis, an IT guy gets a call saying the website is down. And you get to see the natural progression of IT. Imagine if we could change that natural progression of IT and replace that with a intelligent system that keeps the website from going down and keeps callers from calling in and saying, dude, the website's down. So when you get a chance at home, check out The Website Is Down. So that's where I'm going to start wrapping things up. But if you want to find out more, there's actually an opportunity to participate in a workshop at Lisa 16, where we'll actually be working on developing this crazy stuff and figuring out how all these parts go together and what works, what the common language of how GPUs communicate in the data center. And you can find out more at our workshop website, datacentervr.org, or you can hit up the main Usenex website at the link listed there on your screen. With that, I'd really like to thank everybody, including the vBrownbag crew, for letting me up here to talk. If you have questions and you're not in the audience with me live here today, please feel free to use the Contact Us form on Data Center VR, and I'd love to get your feedback on this.